Hello, my name is Don Galarno, and this video is about engineering ideas expressed in crop circles that are perpetual motion, propulsion, and electrical energy generation. The reason this has not been discovered is because these formations make up much less than 1% of the total number that have been made.
Wow.
And it's been in the thousands. It's a needle in a haystack. This has changed today when I show you these new technologies, and there can be no dispute in the interpretations of the pictures portrayed in certain formations. Without further ado, let's take a look at the first formation.
Let's do it.
Without further ado, let's take a look at the first formation. It's not a powerhouse that can energize a civilization, but it can do some useful work. Here the circle makers show a weight and spring assembly right here. There's a weight.
Wow.
Here's the spring assembly.
It's pretty interesting.
With a lightweight body that rotates around the center of mass where the axle is, right here. And as you can see, it's a lightweight body. It's a framework with the axle right here. When the weight is going up against gravity and displacing, right here, the weight will bring the arm in and it will depress down. But the weight never really travels further from the center. So the weight displaces the spring.
Wow. That's pretty interesting.
When the weight is coming down, the spring unloads, and the weight oscillates or yo-yos and pulls on the spring. This device has to first rotate at a critical speed for it to become self-sustaining, and then the device would continue spinning indefinitely. Here we see the weight. Now in 0G, this is what the spring looks like. But in gravity, this spring is going to go this way. And as it bends down, it comes out this way. But the weight stays primarily at the same distance to the center. As it rotates, and in this way, clockwise, the weight comes down and oscillates like a yo-yo.
Gotcha. I understand that part.
And you have to get it spinning at a certain rotational rate.
Right.
After that,
Then it starts going.
Yeah.
Gotcha.
All right.
All right.
This formation is a 3-armed spring that requires tension on the arms so it can be rolled up and the spring compresses into a disc. As you can see here, this is the axle. This formation is a 3-armed spring that requires tension on the arms so it can be rolled up and the spring compresses into a disc. The end of the arms will have a radial rod that is between the arm and cylinder that encompasses the spring device and constrains the arms to its compressed position. Notice that the end of the arms will rest above the junction strap, right here between the two crescents. The junction strap, where it is rigid, this configuration will rotate due to the tension in the arms that is retained when it is compressed, with one end of the spring acting on the axle right here.
So that's the axle in the middle?
Yeah.
Right.
This would be perfect for electric cars. Self-charging cars can be a reality. Now, as you can see, this is a spring compressed into a disc. These are the roller posts I was talking about with the roller wheel.
Yeah.
Here's the cylinder.
Yeah.
The tension is retained in the spring.
Right.
The spring has tension going around in a circle.
Right.
That's torque.
Gotcha.
And this could be in your car charging your battery,
right,
so you don't have to wait 2 hours at a charging station.
Huh. Wouldn't that
Elon.
Yeah, right.
Yeah, give me
Wouldn't
a
that be
call.
awesome, though? I mean, how long would it take, you think,
What?
to charge a car instead of 2 hours?
Those
A lot quicker?
No.
Yeah.
Oh, for this?
For this, yeah, that's what I'm saying.
Oh, well, it depends on how... The next formation was just made in 2023 and depicts a 5-armed spring. This spring has an axle in the center and is compressed and must be unwound. The spring arm will have a stability disc at its end to ensure rigidity, while having a section cut out so that the arm can't transfer an unwanted force to the radial rod and will only exert a radial pressure on the rod that is... Jesus Christ,
Where's the radial rod?
Yeah, this is a radial rod right here.
Yeah.
Here's your disc, your stability disc.
Yeah.
The spring arm wants to go this way and wind up,
Yeah.
but it can't, because in order to do so, it would have to go higher.
Right.
So it stays there. And the stability and the post doesn't have anything to transfer forces to the post. And the post is radial, as you can see, just like spokes on a wheel.
Interesting.
Alright?
Yeah.
And then all you're going to have is radial pressure going down. The radial pressure is going to act on this spring arm, but it's radial.
Right.
And you can see that all 5 arms act together to turn the axle,
In the middle?
which is in the middle, and the spring is coupled to the axle.
Right.
Notice that the arms fork out from the main, so it isn't 5 arms rolled up, it's one, but it branches out depending on where it is.
Ah, interesting.
Yeah.
I see what you're saying.
Ready, get set, go. Another formation shows a cylinder shaped like a hexagon.
What is a hexagon?
A 6-sided figure.
Gotcha.
In the middle of the axle, in the middle is the axle with lever arms that come out and are wound around to occupy a space on the other side of the angled corner that is farthest distance from the axle. The cylinder rotates with the spring arm, and there's no reason to have wheels. So as you can see, here the spring arms come out
Yep.
and they retain
Pressure.
They
Is that what it is?
retain right pressure. They retain pressure on the cylinder,
Yeah.
and the cylinder rotates.
And tightens it, right? And that's where the pressure comes from?
It can't unload. It
Gotcha.
has to keep turning.
I see what you're saying. Yeah. I totally get it now.
Yeah.
No.
The next formation is a spring that can create thrust out of torque. Yes, this is a spring whereby a balanced torque can displace the axle up and over as it travels to the spring center and has radial pressure on half of the axle. Here's the axle.
Yeah.
You add balanced torque to it, it's going to go up. And it's going to go, this is going to go over.
That's the
And
radial
this
pressure?
is going to go down.
Yeah.
And the axle is going to go towards the center of the circle right here.
Right.
The center of mass.
Wow. Pause.
Stop it. Now, as you can see, here's the axle. If I turn it clockwise, it's going to go up.
Yep.
It's going to put pressure on over here to go over.
Yeah.
To go over, and as it's doing so, this is going down. All this pressure is on the axle. Now over here, we have part of the wheel that isn't shown in the diagram, but is absolutely essential that you have it, is a roller pin.
Right.
That's going to act as your brake.
What does the brake do?
It grounds it.
Oh, all right.
It grounds the spring.
Gotcha.
And as you can see, it has a slot.
Yeah.
So that as the spring displaces, this is going to move over to here.
Right.
But that's okay. It's still not putting pressure against this.
Oh, okay.
You see what I mean?
Yeah.
So you've got action, which is
Reaction.
forces on the axle, and reaction, which is forces on the spring, but doesn't translate.
Gotcha.
Before moving on, I want to point out that this spring has to be elastic and rigid, which a material that would be perfect is nylon. You could have the skeleton of cable.
What kind of nylon are we talking? What do you mean? Like what kind?
Nylon.
Oh, all right.
Regular nylon.
Gotcha.
But it has the elasticity that's needed.
Right. So a very tough nylon.
Yeah.
Gotcha.
And this could be used for cars, ships, airplanes, and spacecraft. One can even put this on a mill to generate electricity and just ground it to the arm.
What about a bike? Anything, right?
You could have it on a bike.
Yeah.
So this spring has to be looked at. Now there was another spring that was shown by the crop circles. I saw it on YouTube. I don't know where.
Yeah.
but it was a circle, and it was an off-centered axle with spring arms that went to the periphery of the circle.
Listen, I don't think your audience is deaf. They can hear you, bro.
Okay.
All right. That's just a little humor.
So
ahead.
it works on the same principle. Out of balance torque.
Yeah.
It torques up to the middle of the wheel,
Mm-hmm.
and there's more pressure on one side of the axle than the other, and that is a thrust.
Is that radial pressure?
No.
No.
Well, yeah, it is radial pressure, yes.
Okay.
Very good.
Got it.
The next formation is one of a few that shows a magnetic whirlpool that can energize a coil of wire in the center by way of the flux crossing wires and not requiring the movement of a magnet. Now that sounds impossible, but take a look.
Nothing's impossible.
Yeah, right? There have been several formations showing these whirlpools, and this should be investigated. This formation is a magnet motor, but there are several others showing crescents going around in a circle with the tips pointing at right angles to the radial direction of the cylinder. Some of the flux of the magnet will be forced by another magnet's flux to constrain its path and enforce a whirlpool action. Perhaps this whirlpool of flux can cross a coiled wire and energize it. Keep in mind that flux travels at the speed of light, so there should be a lot of energy. There is no need for a magnet motor because energy. Now, as you can see, these are magnets as well. But we don't care about that. We don't care about magnet motors. What we care about is right there in the center. And as you can see, when the flux comes out, it has to go over to the north. But it's got another south pointing this way. And there's another south pointing this way, causing a rotation of the flux.
And over.
Oh.
There we go.
I don't think
Bring it on.
good.
Action.
This formation shows crescent-shaped magnets connected to spring arms that are connected to a round body and axle. The magnets repel each other and displace, putting tension on the spring arms. The outer half of the magnets attract one another, and an equilibrium will occur when the repulsion and attraction is balanced. The magnets can rest on carts with wheels that roll on the floor, so that large heavy magnets can move with little friction and have necessary support for the large weight involved.
Wow, that's pretty cool. Interesting.
And as you can see, the repulsion happens here.
Right.
All the arms open up and they all act on each other in unison.
Right. Wow, that's cool.
I have two other ideas. One is viable and the other is an experiment. Let's take a look at the viable idea first. Using a body's angular momentum to produce a thrust by spinning heavy wheels, rotating flywheels, and then rotating them orthogonally at right angles, so that a vector force is produced. All the reactionary forces of the motors are canceled out, because the motors are grounded to each other back to back, performing work with their loads being the same. Here's the flywheels. They're spinning 1,000 RPMs, we'll say.
Right.
We got our main motors here that turn.
Yeah.
This is going to turn this way.
Yeah.
And down here is going to turn this way.
So the opposite direction. Gotcha.
Right. All the forces, all the vector forces are going up on the flywheels.
Yeah.
So, with motors and spinning weights,
yeah,
we can create thrust.
And that's where the energy comes from.
Yep.
Nice.
The second idea is to spin a disc really fast and have circuits that travel from the center outwards to the periphery. Have the circuits spiral around in small circles on its path to the edge. Now, one disc will have the circular circuit going clockwise, and another one will have it going counterclockwise.
That was a tongue twister.
Yeah, the Coriolis effect will favor one disc over the other.
Can I ask you a question? What's the Coriolis?
The
What does that mean?
Coriolis effect is on a rotating body. You don't move in a straight line, but you move in a curved path.
Oh, okay.
Hurricanes do it.
Oh, I got you. I know what you're saying.
Yeah. And so you're going to see that as this rotates,
yeah,
we'll say 2,000 RPMs.
Right. Like a hurricane, sort of.
Yeah. And as you can see, there's circular circuits are right here.
Right.
What's the difference between the two discs? One is going to have more of a Coriolis force going with it. And the other one is going to be countering it.
I got you.
So my question is, does that affect the magnetic field that's being created? Or does it affect the mass of the object?
Right.
It's hard to say.
Right.
But one can only experiment and find out.
Right.
This needs to be investigated. Now I ask you, what should we do? Drill, baby, drill and pay for energy? Why not embrace these technologies and transform our system before it's too late? Tell people about this site. Get involved. Please write to me at my email address, ddoonn518@gmail.com. Oil has nurtured our civilization, and we owe a lot to combustion, but its overuse is killing us and turning the world into a hell on earth. It's time to disregard the skeptics and the climate change deniers and just move forward.
Get with the program.
Energy can be created, and there are 3 laws of thermodynamics are just that. Laws that cover heat, gases, and liquids, and the mechanics of a closed system succumb to friction and entropy. We know better now that the proper engineering with solid bodies can do the seemingly impossible. If you notice that these springs must be storing energy in order to do work, even the flux whirlpool can only be done by forcibly positioning the magnets to stay still without flying apart by fastening them in place. Just think, we can have electric heat instead of natural gas to heat our homes, and cars that charge themselves. No need to take 2 hours at a charging station. Oil and gas will have be greatly reduced in their market share, but will always be a part of the energy system. Trains and planes, farm equipment, as well as plastics.
Bikes.
Just to name a few, will still be needed. Finally, I want to share with you my theory on who the circle makers are. A video shows orbs making a circle, and aliens don't have spacecraft that can make these formations. It's ghosts from the other side with alien influence. There can be no doubt that there is life after death, and these formations prove that. It ain't no Jesus with a lawnmower or Allah with a machete. And how do they communicate with the aliens? I don't know. Question: why do they make these ideas so rare and all these formations made? I claim these ideas as my own, and I'm going into philanthropy and will give to charities. This video is proof of my discovery, and there isn't a lawyer in the world that wouldn't take this case.
Thank you.
So I tell you right now, get involved.
And don't use our videos without
NN518@gmail.com. Write to me. Tell people about it. Share this video. We can make a difference.
Let's change the world.
Let's start right now.